Let's let f be the function defined by k times square root of x minus natural log of x for all x greater than but not equal to 0, because you can't take the log of a negative number or 0 unless you want to get into the realm of imaginary numbers. K is a positive constant. So we need to find the derivative and the second derivative. Let's start there. By the way, this is number 6 on the, well, you saw that. This is number 6 on the 2007 AB test. And I don't know why I wrote that in red, but I did. So let's switch colors just for contrast. And f is k times the square root of x minus natural log of x. And so the first derivative is, well, k times 1/2, because that's the exponent, so k over 2, and then x to the negative 1/2 minus the derivative of natural log is 1 over x. And you can put that in the denominator. I'm not yet. And I will later. And then the second derivative will be k over 2 times negative 1/2, so negative k over 4 times x to the negative 3/2, and then negative 1 times negative 1, so positive 1 over x squared. And you can leave it like this. It's perfectly okay. It's perfectly right. There are no problems with that whatsoever. And they're both correct. Nevertheless, I think for the sake of where this is going, I'm going to go ahead and do a little rewrite on them. So k over 2 square root of x minus 1 over x. And negative k over 4 square root of x cubed plus 1 over x squared. And by the way, that was part A. And you will get 1 point for that, 1 point for that. That's it. You got a point here as well. Actually, the answer key has that for second derivative and that for the first one. So they'll take either. Part B. For what value of the constant k does f have a critical point? Okay, critical points occur where the derivative doesn't exist. This derivative always exists within its domain. Or where the derivative equals 0. For this value of k, determine whether f has a relative maximum, minimum, neither at x equals 1. Justify your answer. Okay, so let's go there. Let's do this. I want to take the derivative and set it equal to 0, and then we'll go from there. So k over 2 square root of 1, actually. So here's what it said. What happens at x equals 1? So we'll put that at 1. And then minus 1 over 1. I don't know why I wrote that, but it's equal to 0. So it's where f prime equals 0. Let's be a little more specific, even though we have shown the work that needs to be shown. My whiteout's not working. It's not whiting out. There we go. F prime of 1 equals that, which equals 0. So we have k over 2 equals 1. So k equals 2. Fantastic. Great. We probably got a point for that. I got 2 points for that. I'll go ahead and tell you what we're getting points for. Setting that equal to 0 was a point, and finding that was a point. But we still haven't finished answering the question, and the question actually was, does it have a maximum, minimum, or neither at x equals 1? Well, there's several ways of doing this, but knowing that this is calculator inactive, I think our best bet is to go with the second derivative. Okay, so this goes back to an idea that has been discussed several times. I want to grab a little pink piece of paper here. And if I have a, and I wrote with it with red, it looks sad, doesn't it? But if I have some point right here, obviously it's a maximum, but it's a maximum because the derivative equals 0 there, but also because the second derivative was negative, meaning it was concave down. Or, let's turn that frown upside down. Now, the first derivative equals 0, so horizontal tangent line, but the second derivative is positive, it's concave up, so that would be a minimum. So that's our best bet. Oh, man, 2 of them. So again, when you're trying to figure out if it's a maximum or a minimum or neither at x equals 1, you could do some crazy stuff. Let me grab the scrap piece of paper again. And you could do this stuff that we've done before. Actually, it wouldn't go all the way to negative infinity. It would go to 0, but not include 0. And then we'd have a 1, and then we'd plug in a number here and plug in here into the original function, like f of 1/2 and f of 2. You could do that. But yeah, good luck doing that with natural log. Then you could do it, but who wants to think like that? So it's best if you go with concavity. So let's answer the question, finding if it's a maximum, minimum, or neither at x equals 1. So let's find the concavity at 1. So f double prime of 1 is negative 2, because we found it, right? Negative 2 over 4 times square root of 1 cubed, writing way too much here, plus 1 over 1 squared. So that's equal to negative 2 over 4 plus 1, so that's negative a half plus 1, so it's positive 1 half, which is greater than 0. It might be good to kind of continue your thinking by saying, oh, it's positive. And so here we go. Let's write it out. F has a relative, may not be the absolute, but within its own little region. It's the highest point. Maybe there was something else over here we didn't see. F has a relative, well, it actually wasn't. F has a relative max. Too many humps on that M there. At x equals 1, because F prime, F double prime of 1 is greater than 0. And I just said the wrong word. It has a minimum. I'm sorry. Whoops. Some of y'all might have been way ahead of me on that. Because the concavity is up, this is a minimum point. All right, let's do part C. By the way, the justification. Minimum. And the justification was another one. So the fact that F double prime was 0. Part C. This one's tricky. Let's see what it says. For a certain value of the constant k, now k is no longer 2 necessarily, the graph of f has a point of inflection on the x-axis. Find this value of k. Okay, so here's what I know. When I read this problem, here's where my mind immediately went. Point of inflection is where the second derivative equals 0. So I did this, and I did all this stuff right here. And I was like, okay, great, this equals 0. And I was happy, but I thought, wait, I actually have a k and an x. I don't know what x is. So I read the problem again. For a certain value of the constant k, the graph has a point of inflection on the x-axis. Okay, well, if it's on the x-axis, then the y value is 0, right? So if I'm sitting on the x-axis, so I'm sitting right here, I don't know what the x value is, but it's x comma something, right? So the y value is 0 of the function, not of the derivative or the second derivative, of the function. So I'm going to set the function equal to 0 too. I had to think about that for a little while, and that's perfectly okay. So we're going to set f equal to 0. Well, why in the world did I do that? I'm glad you asked. Because it was necessary. That's why we did that. And so here's the deal. We actually have a system of equations now. So we have 2 equations and 2 unknowns. We don't know k, we don't know x, but we have 2 equations to find them. So let's solve for k. That's the logical one to solve for in both of these. So k in this case is natural log of x over square root of x. And in this case, let's see, we'll bring that over. So we have 1 over x squared equals k over 4 square root of x cubed. We'll multiply by 4 square root of x cubed over x squared. That's equal to k. And by the way, this does simplify a little bit. This is, I'm going to take an extra step here and call this what it is. That's x over 3, x to the 3 halves, x squared. And we'll subtract. So 2 minus 3 halves is going to give me 1 half. That's a square root. Okay, so k is this and k is that. So let's set them equal to each other. Now things get pretty simple. 4 over square root of x is equal to the natural log of x over square root of x. And we can multiply by the square root of x. We can do that because we're not dividing by 0. So 4 equals natural log of x. So x is equal to e to the 4th. Okay, great. That doesn't tell me what k is, but I'm very close now. So I need to know what k is. So k is 4 over the square root of e to the 4th. That's 4 over e squared. All right, fantastic. And so, for a certain value of the constant k, the graph is a point of inflection. Find the value of k. We've answered the question. So now, let's figure out how this thing was graded. We would get a point for this or this. I do believe personal opinion, I think we would need both. They also would give a point for the equation in one variable. And then the final answer. There's your value of k right there.